Alright, welcome again to the meeting rooms problem, but this time we are going to discuss a beautiful approach which we will find and use a lot on future problems, and it's called sweep line. So, again, remember the problem that we are given an array of meeting time intervals represented by the start and end times, and we have to determine the minimum number of meeting rooms needed in order to accommodate all the meetings at every moment of time. So, this is again our example, and as you remember, the answer was 3 here, and what we've basically done when explaining the example and also when solving the problem in the first way is that we are going to find out what is that moment of time in which the maximum number of meetings happen, all of them simultaneously, right? And of course, we have here the moment of time 2, 3, 4, 5, I think even 6, 7, if I'm correct, yes, where there are going on 3 different meetings, right? So now, instead of having that frequency array in which we make all those updates, which as you've seen, a lot of extra memory, the time complexity is huge, we are going to be smarter about this, and we are going to return to what I've actually done when explaining this example, right? So what did I do? I've just acted like in the real life, and like I was that greedy manager which won't make any room available until it is really needed, right? So, in order to do that, I need to go through these events, and by an event I mean whether a meeting starts or ends in chronological order, right? So, I was going through the events, and this technique is called sweep line because you can imagine a line, right, with my pointer. You can imagine a vertical line which is going through the OX or the time axis in order and figures out what happens at each event. So with this sweep line, I'm going to go through all the events in chronological order, and what I'm interested in here is actually the number of meetings that are taking place at that specific moment, right? So let's have a variable, let's call it, I don't know, no, right, from numbers, and of course it's initially 0, right? So what am I gonna do is that I'm gonna start at the moment of time 0 where something changes. I encounter the first event, and the first event, because it's an open parenthesis, this tells me that a meeting is going to start. So the number of meetings taking place at the moment of time 0 became 1. Then, no other event at moment of time 0, I go to moment of time 1, and I see another open bracket. Alright, this means that the number of meetings that are taking place at this specific moment of time is now 2. Then go to the next moment of time, which is 3. I have no event, so of course the number doesn't change. 4, again, nothing starts or ends, no changes. Then I go to the moment of time 5. And what I'm gonna do here is that I will first take into account the end event, right? Because technically, the end event happens before the beginning events at that moment of time, right? So, the end event tells me a meeting just finished. So the number of meetings now is 2, but another one, the next event at the same time moment, tells me that other meeting started. So what I'm gonna do? I'm gonna go back to 3. And this is indeed right. At moment of time 5, 3 meetings are taking place. 6, nothing happens. Still 3 meetings taking place. 7, 1 meeting is now finished. So I have 2. And then another one starts. So I have 3. Move on. Moment of time number 8. I have only 1 event and the meeting ends. So I have 2 meetings happening at the same time here. Am I right? Of course. It is the meeting number 4 and the meeting number 2, which didn't end until now. Then I move to the moment of time 9. A meeting is finished. one meeting happening at this moment of time, also at 10, and at 11, of course, also this meeting is over. So you see what I've done? It's very simple. Once I am able to go through all these events in chronological order, right? This is very important, because if I take a look at the input, going through the time intervals in the order they are given is not enough, right? So the first meeting that is in the input, the first interval is 1, 5. But actually these three events are over here and over here, so I can't go through them, the first ones, because something happened before, and this is important. So once we will be able to go through these events in chronological order, and probably by now you have understood what I'm saying by this and the hint that I gave you, then everything will be simple. I'll just hold these variable numbers, and all I have to do is that when I encounter an event of the first type, which is start of a meeting, I just increment the variable, and when I encounter an event of the second type, which is the end of a meeting, I decrement the variable. And this is it, right? Only have one variable, and of course, what's gonna be the answer? Well, the answer is obviously not gonna be the value of the variable at the end, because if your algorithm is correct, this variable should also be 0 in the end, because every meeting starts and ends at some moment of time. But it will be the maximum value it has ever had, right? Because the maximum value means that at some moment of time, there were that many meetings happening simultaneously, right? So all we need to do is for each event, update the variable and update the answer if the value of this variable became greater than the current one. And this is it. The only question remains, how should I traverse these events in chronological order? And by chronological order, of course, we mean the moment of time. So all the S0s and E0s from the input, these are the moments of time of the events, and each event also has a type. So why not sort them, right? An event could be determined by two values: the time moment it happens and its type. So we can denote the open brackets or start points of a meeting by the time moment it happens and 0, for example, and the endings by the time it happens and 1s, right? Alright, so let me erase this and show you how these events will look for the example input. For this example, let's see. We are going to look at each time interval, and for each time interval, we are going to push exactly two events, the start and the end, in the events array. Of course, the array consists of pairs, because as we've seen, it is important to also know the type of the event, right? We can't do anything only with the time moment, because we don't know if it's open, so we should increment the answer or the number of intervals, or if it's closed, so we should decrement the number, right? So obviously I have only the input, I don't have this drawing, so I have to relate to the input, and I see first time interval 1, 5. What are the events here? Well, we have one event happening at the moment of time 1, and the type of the event will denote by 0, so 0 means start of a meeting, and the second event here happens at the moment of time 5 and has the type 1, which means end of the meeting. Then the next one is 2, 7, right? So I have first event here, moment of time 2, type 0, and the second one, moment of time 7 and type 1. Next one, 0, 9. What's gonna happen here? First event 0, start of the meeting. Second event 9, end of the meeting. Next one, 5, 8. Awesome. 5 and start, 0. 8 and end. And of course, the last meeting, which we have the event 7, 0 and 11, 1, right? So, after going through all the time intervals and making the events, we will be left with an array of pairs of integers, where the second integer is actually a Boolean, 0 or 1, and yeah, there will be 2 crossed n of them, right? Because if there are n time intervals, 2 crossed n events. Now, as you can see, of course, the events array is also messy. The first event is at the moment of time 1, the second one 5, then 2, then 7, then 0, so obviously this is not a chronological order. But in order to get a chronological order, as we said, all we have to do is sort the array of events by the first value, so by the moment of time, right? Because when we deal with pairs, we need to know the criterion of sorting them. In this example, we are going to sort them by the first value, and in case of equality, for example here, we can sort it by the second value, but as I think about it, it doesn't even matter, does it? Because if at some moment of time, I mean, yeah, the ends of the meetings theoretically happen before the starts of other meetings, but no matter the order in which we deal with them, we are going to end with the same number variable at the end of all of them, right? And this is all that's important. I mean, it doesn't mean what intermediate values the number had. It's only important what's the final value of number after dealing with all the events at some time moment. So it's cool. We can only sort them by the first value, and that is enough. Let's sort the array and see how it looks. And this is how it looks like. Now that we have just sorted it, we actually don't care anymore about the first values. We can ignore them. All we care about are these second values, right? Because all we need to do is, if we have as the second value in the pair a 0, increase the number variable. If we have a 1, just decrease it, right? So let's see. Number is 0, right? We have a 0, right? It becomes 1. The next element in the sorted events array, another 0, another event happened, 2, right? You can look here or you can look here. Now they are exactly the same. Another 0, 3 meetings happening. Then we have a 1, right? So the 1 is here actually. So now we decrease it, and so on and so forth. You got the idea. It's exactly what we've done here with our sweep line. Notice that we don't need any like crazy geometrical stuff or stuff like that. Only in order to be able to go chronologically, we needed an array of pairs, which we then sorted, and we have our answer. Now let's implement it and see the time complexity of the algorithm. Alright, and here is the algorithm. So, first of all, we are starting off with an array of pairs, which is initially empty, and then for each pair of start and end points from our time intervals from the input, we are just pushing 2 pairs. One consisting of the event that is the start time of the meeting and of course type 0, and then the end time of the meeting and of course type 1. After pushing all these pairs, so we will have the events array of length exactly 2 cross n, we are going to sort it, and I think in every programming language, when sorting an array of pairs, they are going to be automatically sorted by the first element in that pair, or if not, maybe in JavaScript or something like that, you can give like a comparison function, but that's not the important thing here. After we sort the array of pairs, we are starting with 2 variables, answer, which is initially 0, and the number of intervals, which is also initially 0. Then we are iterating through all the events here. So for each pair consisting of the time the event happened and the type of the event, we are basically checking if the type is 0, of course, we will increase the number of meetings that are occurring at that moment, and else that means that a meeting just finished, so we will decrease the number. And after each event from the array of events, we are going to update our answer, right? Because now we know at that moment of time how many meetings are happening at the same time, so we can update the answer with the value of number of intervals if this value is of course greater than our current answer. After doing all of that, we just return the answer and that's it. So let's analyze the time complexity of the algorithm. So basically, the first part, which is building the events array, how much time complexity do you think it takes? Well, obviously this initialization is constant time because the array is empty, and then iterating through each pair of intervals and pushing 2 pairs. So pushing 2 pairs is of course both of them constant time, so we can say 2 operations here, doesn't really matter. And we do that for each and every interval, and there are a total of n intervals. So this part, the whole of it, is big O of n. Now, after we build the array of pairs, we are going to sort it. And this is the important part here, because sorting an array of n pairs is also big O of n, pairs of integers, of course. If there are strings, then the length of the strings comes in play. But only for this is big O of, excuse me, rookie mistake, is big O of n log n, right? So we have a big O of n log n from here. It would have been big O of n if, of course, applying some radix sort or counting sort, only if we can. But in this example, the start and ending points could be huge, so there's not that case, right? Now, initializing these variables, of course, is also constant time. So we have a big O of 1 from here. Returning the answer is, of course, constant time. So big O of 1 here. And then we have our main for loop, which the only thing that does is it iterates through each and every event, and it has an if statement with its corresponding else. And in each of these scenarios, whether if it's the if statement or the else one, we just have an addition or a decreasing operation. So of course, constant time. And yeah, the only question is how many iterations does the for loop make? And of course, it is equal to the number of events, which is 2 crossed n, but ignoring the constants here, we have a big O of n from here, right? So as you can see, the most time consuming part of this algorithm is actually sorting the array of pairs, which is big O of n log n. So we can say that this algorithm has a final time complexity of big O of n log n. And this is it. Of course, it's way better than the big O of n crossed max time. And yeah, that's only the time complexity. But also, if we think about the memory complexity, what's gonna be it? Well, we are using an extra array, which is events, which keeps track of n pairs, so 2 crossed n integers. So of course, that's gonna be big O of n, right? So we just came up with an algorithm of big O of n log n time complexity and big O of n memory complexity. Hope you enjoyed it, have fun coding, and as always, see you on the next one.